Okay, so I'm not sure what happened with the previous video. Anyway, I got a proper microphone too. I'll go over the code, what I did, and I'll explain every part of it. So we have models, we have chains model. The EVM chain is basically just an RPC URL and an instance of Web3. I will add like base chain will contain like multiple RPC retry mechanism, maximum block, stuff like that, stuff related to the RPC provider and particular chain. We could also create a Solana chain. Like this is just a base model, which is fabulous. The the way it's modulable. Um, so that's a chain model. We have a base AI agent that's nothing right now, but we can define basic stuff in it, and then create new agent that inherit the base agent. So this is the virtuals. Sorry, there is a S missing, but that would be this is all the data that happen when the specific function when the virtual address deploy a new token. This is the data that is contained. There is the ID of the virtual, the token, the DAO address. I don't remember what's the TBA, VA token, neither. LP is the liquidity pool, the date that was created, and this is just the timestamp that we create for us. So this class represent what's the AI agent is. Of course, the token is actually the crypto that's behind it, but still, this is just an object. Uh, in the same file, I made the listener. So the listener basically listened that address. This is the address that deployed. That deploy. Let me just. I'll show you. Uh, so if I go on base scan, just gonna be sure the video is recording. Um, so 42 days ago, execute application. Uh, basically, uh, so execute application 42 days ago. Transfer pair created, liquidity pool created, initialize, approval. This is all event in the transaction, but uh, the particular event that we want is found it. Jeez. New persona. So as you see, new persona, the virtual ID, the token, the DAO, the TBA, the VA token, the LP, all that. I think new persona. Oh, it's not there. Let me just explain you which part is what. What? Yeah. So new persona. The agent token, the liquidity pool, and the initial liquidity C2 agent V token, agent DAO, agent NFT, TBI. I'll check what is it. So create new agent, the liquidity pool stuff, add initial liquidity, the VA token, create new agent VA token. I I think that's mostly in the ecosystem. They have their own token for different stuff. They have the agent have its own DAO stuff like that. Also the NFT, which the virtual ID is fetched from. Uh, then this is ERC 6551 TBA. So TBA is non-fungible token bound address. TBA token bound address. Okay. And 7 staking the V token. Yeah. So basically, that's the function that is called when there is a new agent coming on the market. Like I checked the old contract, and I thought about it. Like this is the function that we need to listen. Each time a function like that, each time that event is sent, it means a new agent is created on the platform of virtuals. So the last time it happened, it was 42 days ago at the this block. No, sorry, this block. So that's why new persona, you can see that's the event that I want to listen from that address. This is particular for that RPC because the RPC that I'm using is free, so I can request data only once per second, I think, and the maximum block range is 10,000. I don't know where this is like that, but doesn't matter. That's weird. So when you initialize virtual agent listener, it's getting the web3, it's creating its own instance of web3, um, RPC URL, yeah. Then it's loading the contract of the deployer address with its ABI. We get the database collection too, and the starting block, which is I've put one block before this block just to prove you that it's working. Then there is a function in that class that's called fetch past event. That's basically getting all the blocks from there, also respecting the the block range and the maximum rate limit per the. In that case, it will be per the EVM, but I just hard coded there. We are using get logs because this is available in public free RPC, and we are getting all the new persona events. When there is, we process the event. Monitor new entry is basically the same. We just start from lattice block, um, and we just continuously monitor for new events, for new block that happens since we did monitor. Uh, Process event, get all the data from the event, which is all what we just checked, and we are inserting it in the database collection. So that is the two classes that are for virtual agent. So in another case, we could have another EVM compatible agent deployer that we want to listen, or even Solana. Basically, we just create a new configuration for Solana, not EVM, and we will create an agent model for that particular model. The same way, instead using, let's say, Web3 RPC, we would use another. Uh, I think Solana actually work with Web3. I'm not sure, but anyway. So, like as I said, this is just a base. This is just for the sake of it, but you get the point. That's models. That's how I represent what we want to get. So, and same thing for chain, same thing for agents. So, in the main script, we are initializing the database configuration. Here, I will pass this in the EVM chain, but for the sake of the test, I'm just hard coding that. So it's an EVM chain and the RPC address. So we're passing that to the chain config. Chain config here, chain type EVM, and the RPC, we initialize the Web3. Actually, I don't think we need to load the Web3 here. It's not very important because we load it elsewhere in the code. It's not. I'll take all that in notes. Then we in a string we get the listener name. So basically, we get from models, agent, virtual AI agent, and the class virtual agent listener. We put it as a string in that, and we send the RPC URL as parameter. This way, we can uh, I just I just comment this one. We can call fetch past event. This is a celery function to celery here. Um, because here it was loaded from celery task, which I will show after. But we use delay, listener class path, which is this, listener parameter, and the database configuration. When that is triggered from celery task, okay, so we create a celery app which use Redis. Then we have two functions. We have we have two celery tasks: fetch past event and monitor event. So it's basically workers that are scalable. Fetch past event accept the dotted path to the listener class, example this one, and any parameter that will be required, and the configuration too. We get all this. We dynamically import the listener class. We initialize it here, and then sorry, we initialize it here, and then we call fetch past event. Same thing for monitor. It's basically the same process. So this celery app is going to load uh, this function fetch past event, but using celery, which is scalable, and how can I say this? You can spam a lot of parallel workers. You can even structure it in a way that you have an Amazon um, structure that's going to deploy server on need per celery worker, stuff like that. It's very scalable, and it's the best thing to scale Python backends, in my opinion. So I'll show you what it looked like. What is the result of this? So I just start my Redis system, which work on WSL for whatever reason. So we have Redis working here. Then I'll get Celery working. We use the pool solo on Windows because multi-thread is not supported on Windows. But I tried it on Linux. Like it just spam like 7 worker and they do the task by themselves. Um, I need to check something though related to not having duplicate in the database. So we start the worker like that. You can see the tasks here are loaded in Celery. You can see some configuration here. We are connected to Redis, and the Celery application here is ready. So if I run Python main, it's going to dispatch the task listener with the parameter and the configuration, which is basically fetch all the past events from that block. So we should get one result because that function, that transaction is what we want. So the code dispatch it, and then you can see here we found one event in that block range, and it's still gonna fetch more block because the time is this is an old block, so it's still gonna fetch from a 2 up to now. And we could also use the other function, which is monitor event, which is from now until we stop monitor. Okay, I'm just gonna close it again. You see the task were dispatched once and the script exit. Uh, because we don't the task were celery is the worker, it's not the Python script itself. So the goal is to let's say have monitoring multiple chains. On these chains monitor multiple agents, so there is a task for each agent. And let's say the screener to fetch some data. So a task for each token crypto that we have to let's say get market data. But we can still implement, like, let's say there is a limit of requests for that API for Dex Screener. We can be sure that the workers that do the Dex Screener task will respect something like limiting, like a rate, or use the same API, etc., etc. Because we can create a model that's gonna create our fetcher from Dex Screener. Then we get data in the database. You can see here biscuit.fun was created. AI agent, we got one AI agent. So from now, we can get, let's say, the token from that particular case for virtuals. What we want is, let's say, the financial data of tokens. Also, this is not valid. This is now, but we can still, it's gonna get the Unix timestamp from the block. I just did use now for now. Um, but this is all the data that we can extract from virtual, from the creation of a new virtual. We could then run a text screener on the token data and store that in another place in the database, and then we serve all these data to an API. So if someone go on virtual agent 679, we see this, we have this data plus, let's say, the text screener data for that virtual ID, for that token, etc., etc. So that's the base structure. I think it was important to do the video. Sorry for delay. But the way it's structured, it make it very modulable for new chains, EVM or not, and also new agent and new task itself.